Hello, this is the recording for the Intervlan routing using a layer 3 switching configuration. In this configuration, the approach to Intervlan routing using layer 3 switching, a switch virtual interface is configured on the layer 3 switch. This switch virtual interface serves as the default gateway for hosts in each VLAN. This is similar to the configuration mentioned in Netacad section 4.3.3. The configuration shown provides two additional capabilities. A, the ability to ping hosts in different VLANs that are connected to different Layer 3 switches, and B, the ability to ping an external host, in this case 209.165.100.10. Both features are facilitated by connecting the two Layer 3 switches using a trunk. Note the requirement to specify encapsulation .1q when configuring the trunk port. Shown here is the configuration for multi-layer switch 0. Interface VLAN 10 serves as the default gateway for members of VLAN 10, host machines connected to VLAN 10 ports on this switch. Interface VLAN 20 will serve as the default gateway for host machines connected to VLAN 20 ports on this switch. Ports 1 and 2 are members of VLAN 10. Ports 5 and 6 are members of VLAN 20. IP routing is turned on. It's important to note that the trunk line connecting these two switches has to first be configured encapsulation.1q and then switch port mode trunk. Let's look now at the configuration of multi-layer switch 1. Again, we defined VLAN 10 and VLAN 20. Now notice on multi-layer switch 1, switch virtual interface for VLAN 10 is .2 as opposed to .1, and this .2 will serve as the default gateway for host machines that are connected to VLAN 10 ports on multi-layer switch 1, and similar with VLAN 20 ports. Host machines connected to VLAN 20 ports on multi-layer switch 1 will use .34 as the default gateway because that's the switch virtual interface for VLAN 20 on multi-layer switch 1. The trunk line connecting these two switches, encapsulation.1q is configured, and switch port mode trunk. This is the first screen capture, PC0 pinging PC3. PC0 is a member of VLAN 10, PC3 is a member of VLAN 20 on a different switch. In this screen capture, make sure you get the name of the PC. Capture 1. PC0 pinging PC3. PC0 is in VLAN, is connected to a VLAN 10 port. On multi-layer switch 0. PC3 is connected to a VLAN 20 port on multi-layer switch 1. Notice the name of the file, student name, intervlanRouting, layer 3, layer 2, because we're doing layer 3 first in our example. Here's our second capture. Caption, capture 2, PC0, pinging 209.165.100.10. That concludes our Layer 3 switch interVLAN routing. Now on to our Layer 2 interVLAN routing with the help of an external router. Here's our network, where we're using Layer 2 switches to provide interVLAN routing with the help of a router. We've also configured here a hub. That's just a listener on its 82.1q trunk. This PC would have a sniffer listening. This is what we set up in class. Here's our configuration for S1. S1's on the left, S0 is on the right. Here's our router, R0. We declare the VLANs, VLAN 10, VLAN 20. We do our port assignments to the VLANs, and we configure the trunk port. Let's drop this in switch 1. Check for errors. Switch S0. Check for errors. And the router. There's our router configuration. Using our 82.1q encapsulation, .10 and .20, and we also have G01, which is directly connected to the external server. Copy. Check for errors. The only errors are enable and config terminal because we were already in global configuration prompt. Let's check connectivity. PC0. Can PC0 ping .38? PC3. Okay, we have a successful ping from VLAN 10 to VLAN 20. Now let's see if we can ping that external server. And we have success. Okay, so here's our only screenshot for this network. We're going to be in the debugger simulator, ICMP, and we just want to see the packet go up to the router and then down to PC3, which is .38. We're in the simulator. And we just want to open that frame. Inbound. Notice the G00's IP or G00's MAC address is 2501. That's the destination for this frame. So capture that. Make sure your name is in the background. So we have the ping. We have success from the previous ping. Now we're doing it in the debugger. And we see the destination MAC address is 2501. And that matches with what we see here. Capture that. Make sure you capture PC0 up there. Edit copy. Go to our Word document. It's the third and final capture. Notice in this capture we have a lot. It tells us PC0 has already successfully pinged 209.165.100.10, so we know we can get out. Now we're pinging 138 or .38, which is on another VLAN. We're capturing that in the simulator, and it shows 2501, which is the MAC address of gigabit 001 on that router. It also shows the source being .1.5, which is PC0. Capture 3. PC0 has successfully pinged 209.165.100.10. PC0 now pinging PC3, captured PC3. Captured frame shows the destination MAC address as R0 gigabit 000 MAC address. 00E0 F903 2501. That's the last capture, and that concludes this video.